Welcome back everyone. This is Unit 3 Idea to Concept Part 3. Just to let you know that the course code has now changed from CSC 30 to CSC 300. Let's get started. This week's overview, we are going to look at 3.5 standards and 3.6 presentations of technical drawing. By the end of the lesson, students will be able to understand ISO standards, explore presentations of technical drawings. You might wonder and ask yourself, what is the meaning of ISO standards? Firstly, ISO is the International Organization for Standardization. It's an independent, non-governmental international organization that develops standards to ensure the quality, safety, and efficiency of products, services, and systems. Continuing with these standards, engineering drawings must meet accepted standards with most countries using the ISO standards. Speaking of standards, we're going to look at the paper sizes as one of the international paper formats. If you look on the picture on the right, you will see different type of paper sizes. First one being the A0, the biggest size of paper. Then we have half of that being the A1. A0 is 1189 millimeters, whereas the A1 is 594 millimeters. You can then have a guess of which one will be half of the A1. Yes, you've guessed it correctly. It's the A2. A2 is half of the A1. The half of A2 will be A3. And the half of A3 will be our usual A4 paper size. Let's move on to scales. The objects in our daily life are usually either too large or too small to be drawn on the actual size, which is true. If you have a big object, you cannot fit this big object on a piece of paper. Therefore, our largest size of paper under the ISO standard is the A0, which is a lot smaller than obviously the object that we have in real life. The engineer needs to scale drawings that are either smaller or bigger than the actual objects to fit the paper. Next, we have something called a scale. Now, the meaning of a scale is just the ratio dimensions appearing on the drawing compared to the original object. Since scales are a ratio, they have no units. As you can see, these pictures on the right represents different type of ratios. We call this one 1:2 ratio, 1:1, and 2:1. I'll explain that in details in the next slide. Scales are commonly used in engineering drawings. The true size of an object, as an example, is 1:1. We can then reduce the sizes accordingly. The reduction of the true size could be 1:2, 1:5, or 1:10. We can do the opposite of enlarging, which is 2:1, 5:1, and 10:1. The scale 1:1 means that the object has been drawn to its true size. A scale 1:2 means that the object has been reduced to its half size. And scale 2:1 means that the object has been enlarged twice as its true size. Let's talk about lines. In engineering drawings, different lines and line styles are used, commonly used in engineering drawing and their applications. Let's look at the first type of line. We have a line called continuous thick line, which looks like this here, and is applied as object line. The second one, we have continuous thin line, which looks like this, and it's used as dimensioning line. The third one is the short thin dashes, as you can see here, and this one is used for non-visible outline, most of the time hidden. And the last one, thin chain line, which is basically just used for central lines. We have something called axonometric projection. Now, axonometric projections are drawn in 3D. They show the length, the width, and the height of an object in one drawing. Two standards are currently used for the axonometric projections: diametric projections and isometric projections. Here are the explanations of the two types of projections, diametric and isometric. Now, diametric is very important to understand that these are used with two axes on the drawings, whereas the isometric uses three axes on its drawing. The dimensions for the diametric projections along the third axis are halved. This projection is preferred when one view of the object is to be emphasized than the other two views, whereas the isometric is preferred when the three views of the object are equal and are accurate on the presentation. As you can see here, you can see that the most important axes have been explained here for the diametric projections, whereas the isometric uses three equal sides as a view, one here, one there, and the other one being here. Let's move on to something called orthographic projections. An orthographic projection, which is abbreviated as OV, is mainly used for two-dimensional views and shows only one side of an object and two of its overall dimensions. In an orthographic projections, the views are seen in the directions that are right angles to each other. A minimum of two orthographic views is required to show the three dimensions of any object and to describe its shape completely. Some features of the object cannot be seen, known as the hidden details, and that will be shown on the next slide. As you can see, the hidden ones are the dotted lines. The three chosen views may be of any of the 6 hypothetical faces of the object. These views are named as the below. We have 6 different type of views. We have the bottom view, which is at the bottom. We have the front view, which is at the front. We have the side view, which is at the side. We have the top view, which is at the very top. We have the rear view, which is at the back. And we have the right side view, which is right here. These are the 6 hypothetical faces of an object. Standard orthographic projections. Two standards are commonly used in orthographic projections of drawings. We have one called first angle projection, which is mainly used in Europe, and we have the third angle projection, which is mainly used in America. The corresponding views are identical in both methods of projection, except for the relative positions on the drawing paper. Here is a good example to show you the front view, the left view, and the top view of an object using the standard orthographic projections. Here is the main object on the left, and these are explained as the first angle projection, and this here is the third angle projection. Now you can see the main difference between the first angle projection and the third angle projection. The first angle projection has a unique feature, which is the dotted lines, whereas the third angle projection hasn't. I'd like you to watch a video on axonometric drawings next.
Hi guys, Umar here for Architecture Daily Sketches. Thank you so much for your engagement with our previous video on line weight. This week, our topic is axonometry. Now, an axonometric projection is a type of parallel projection where the object is rotated along one or more of its axes relative to the projection plane. That means, if you have an object like this, it would be tilted like this before it is extruded along its vertical axis. Now, I prefer to tilt it 45 degrees on both horizontal axes as it preserves the plan to be true, as none of its axis is distorted like in an isometric projection. Axo is also great for showing multiple facets of objects in the same drawing. Now, there are a lot of cool technical tutorials out there that do teach axonometric drawing using T-squares in a triangle, but for this channel, we are all about the guy sketching on the go with nothing but pen and paper. With that in mind, I would like to talk about an aspect of axonometry that would be perfect for sketching, and that would be developing your concepts in a diagrammatic manner, as using axos is perfect for showing an experiment with massing and expressing form and multiple facades. And not everything can be shown when sketched in perspective as well. Now imagine if you have a site on a river and you have an initial idea of a house crossing the river like a bridge. You could also develop the form to respond to its context by using diagrammatic arrows to show the sun path and wind movements, and that's usually more informative in an axonometric drawing, much easier to see. Now these developments can be developed and can be shown through multiple diagrams stretching a whole series. This is incredibly helpful for explaining your design process. In fact, you could even flesh out your axonometric diagram with human figures and trees as a final iteration for presentation to really showcase your great idea. If you like this video, please thumbs it up, share it with your friends. You can follow us on Facebook or Instagram, links are below. If you're new here, please subscribe for more videos. Thank you so much for watching.
Now please make sure to subscribe, like and share, and most importantly, try and complete all the worksheets given in order for me to give you a mark. Thank you very much for watching. Goodbye.